Debden Airfield, Essex, England. Major Don Blakesley stands in the operations briefing room, staring at a map that shows something he's been ordered to do but knows is impossible. The red line stretches from England across the Channel, over occupied France, deep into Germany, all the way to Berlin. 1,100 miles round trip to the target. 1,650 miles, accounting for combat maneuvering and evasive action. His P-51B Mustangs, the finest fighter aircraft in the European theatre, have an operational combat radius of 650 miles. The mathematics are simple and unforgiving. Berlin is 200 miles beyond his fuel capacity. Gentlemen, the intelligence officer begins, starting next week, 8 Fighter Command will escort heavy bombers to Berlin. The room erupts. Blakesley, commander of the 4th Fighter Group, doesn't raise his voice. He simply states facts. Our Mustangs can't reach Berlin. Not with combat reserve. Not with any margin for error. You're asking us to fly into Germany, knowing we'll run out of fuel somewhere over Bavaria. The briefing officer responds with the answer everyone already knows. External drop tanks, 75-gallon tanks under each wing. Blakesley has heard this solution before. The 75-gallon drop tanks exist. They work. They're also completely inadequate. Even with 2 75-gallon externals plus the P-51's internal 85-gallon main tank, total fuel capacity reaches only 235 gallons. The Mustang's Rolls-Royce Merlin engine burns 65 gallons per hour at cruise, 120 gallons per hour in combat. The math is brutal. 235 gallons at 65 gallons per hour gives 3.6 hours endurance. At cruise speed of 290 miles per hour, that's 1,044 miles maximum range, 0 reserve. Combat over Berlin would require at least 30 minutes at combat power. That's 60 gallons. Subtract that from total fuel, and effective range drops to 870 miles. Berlin is 1,100 miles round-trip minimum, 1,300, accounting for weather routing, 1,650 with combat maneuvering. Blakesley's pilots are being asked to escort bombers into Germany, knowing they'll be gliding back across France on empty tanks, hoping to find somewhere, anywhere, to set down before the engine quits. The desperation driving this impossible mission comes from casualty statistics that are destroying the 8th Air Force. Between October 1943 and February 1944, American B-17 Flying Fortresses and B-24 Liberators have attempted daylight precision bombing deep into Germany. The theory behind daylight bombing is that American bombers, flying in tight defensive formations with interlocking fields of fire from their 50-caliber machine guns, can defend themselves against German fighters. The theory is wrong, catastrophically wrong. October 14th, 1943, the second Schweinfurt raid becomes known as Black Thursday. 291 B-17 seconds attack ball-bearing factories deep in Germany. German fighters, Bf 109 seconds and Fort W 190 seconds, attack in waves. The bombers shoot back with everything they have. It doesn't matter. 60 B-17 seconds are shot. Down. 600 men killed or captured. 138 bombers return damaged, 17 so badly they'll never fly again. That's a 26% loss rate on a single mission. Statistically, a bomber crew assigned to fly 25 missions, the required tour of duty, has a 3% chance of surviving. Before we jump back in, tell us where you're tuning in from, and if this story touches you, make sure you're subscribed because tomorrow I've saved something extra special for you. The problem isn't courage. American bomber crews are among the bravest men who ever flew. The problem is range. American fighters can't escort the bombers deep into Germany. P-47 Thunderbolts, the primary escort fighter in late 1943, have a combat radius of 425 miles. They can protect bombers to the German border, then must turn back. From that point forward, the B-17 seconds are alone. German fighter controllers position their aircraft beyond P-47 range and wait. When the American escorts turn back, the slaughter begins. Luftwaffe fighters attack from head-on, exploiting the B-17's weakest defensive arc. They use 20mm cannons and 30mm rockets to kill bombers from beyond 50 caliber range. Between August 1943 and March 1944, the 8th Air Force loses 2,200 heavy bombers, 22,000 men killed or captured. Entire bomb groups are decimated. Some squadrons lose so many crews they temporarily cease operations. General Ira Eaker, commanding 8th Air Force, understands the crisis perfectly. Without fighter escort all the way to the target and back, daylight precision bombing is unsustainable. The losses will force a shift to night bombing like the British RAF, abandoning the precision targeting doctrine that justifies the entire strategic bombing campaign. The P-51 Mustang offers hope. Designed by North American Aviation in 1940, the Mustang originally disappointed. Powered by an Allison V1710 engine, early P-51 seconds performed poorly above 15,000 feet. But in 1942, someone had the idea to mate the Mustang's airframe with the British Rolls-Royce Merlin engine, specifically the Packard-built V16507 variant. The transformation is extraordinary. The P-51B with Merlin engine achieves 440 miles per hour, maximum speed at 25,000 feet. It climbs to 20,000 feet in 7.3 minutes. Its laminar flow wing design creates exceptionally low drag, making it the most fuel-efficient fighter of the war. Crucially, its 85-gallon internal fuel tank plus two 75-gallon drop tanks give it unprecedented range. By early 1944, P-51Bs are arriving in England by the hundreds. 8 Fighter Command begins transitioning groups from P-47 Thunderbolts to Mustangs specifically for long-range escort. The strategic calculus is clear. If Mustangs can escort bombers to Berlin and back, the entire air war changes. German fighter production, concentrated around Berlin and other deep targets, can be destroyed. The Luftwaffe, forced to defend in strength, can be systematically annihilated. But the P-51B's 650-mile combat radius isn't enough, not for Berlin. Engineers calculate that escort to Berlin requires 950 miles minimum range, preferably 1,000 miles with safety margin. Multiple solutions are attempted. North American Aviation designs 108-gallon drop tanks, paper design only. Production won't begin for months. Too late. Engineers propose installing a 65-gallon fuel tank behind the cockpit. The modification is approved and begins production. But retrofitting existing aircraft in England takes time. March 1,944 missions to Berlin need an immediate solution. The British propose paper drop tanks, disposable fuel tanks made from treated cardboard and glue. They're lighter than metal tanks and slightly cheaper. American pilots take one look and refuse. You want me to fly 600 miles over Nazi Germany with my extra fuel in cardboard tanks? What happens when fragments from flak or cannon fire hit them? Somebody suggests flying higher, where thinner air reduces drag and improves fuel economy. The bombers fly at 25,000 feet. Fighters escorting them must fly higher to maintain tactical advantage and must constantly weave back and forth to avoid overrunning the slower bombers. The weaving burns extra fuel. Flying higher doesn't solve the problem. Someone else proposes reducing combat time over target. Escort the bombers to Berlin, then immediately turn back instead of protecting them during bomb runs. The bomber commanders reject this instantly. The most critical moment, when bombers are making their straight and level bomb runs, is when they're most vulnerable. That's exactly when they need fighter protection most. By March 1944, the operational planners face a choice. Either cancel Berlin missions until longer-range solutions arrive, or order fighters to attempt the mission knowing they'll run out of fuel over Germany. The first option means abandoning daylight precision bombing. The second option means accepting that some percentage of fighter pilots will be lost, not to enemy action, but simply to fuel exhaustion. Neither option is acceptable. What nobody in 8 Fighter Command Headquarters knows is that 220 miles away, at Debden Airfield, a technical sergeant who never graduated from engineering school, never worked for North American Aviation, and never designed anything in his life, has just figured out how to add 65 gallons of fuel capacity to every P-51 inches the European theatre. His modification will take 45 minutes per aircraft. It will cost exactly $0. And when the commanders see his solution, their first reaction will be to court-martial him for destroying government property. And his forbidden modification is about to make the impossible possible. Technical Sergeant Robert Bob Shafer is not the kind of person who revolutionizes aerial warfare. He's 24 years old, 5'9", skinny, from a small town in Ohio. Before the war, he worked at his father's garage, fixing tractors and farm equipment. When he enlisted in the Army Air Forces in 1942, he scored well enough on mechanical aptitude tests to avoid infantry assignment. The military sent him to aircraft maintenance school, 6 months learning how engines, hydraulics, and electrical systems work. He graduated middle of his class. Nothing distinguished him from 500 other mechanics. In October 1943, Shafer ships overseas to England, assigned to the 334th Fighter Squadron, 4th Fighter Group at Debden. His job is maintaining P-51B Mustangs, specifically engine and fuel system maintenance. It's repetitive work: pre-flight inspections, oil changes, spark plug replacements, fuel line leak checks. Shafer is good at it. His aircraft rarely have maintenance delays, but he's not an innovator or a designer. He's just a mechanic who follows technical orders and does his job competently. What makes Shafer different is that he pays attention, not just to his assigned aircraft, but to patterns. In January 1944, he notices something during post-flight inspections. Pilots are landing with fuel remaining in their drop tanks. The P-51B carries 2 75-gallon external drop tanks, one under each wing. Standard operating procedure says burn external tanks first, then switch to internal tank. The reason is simple. External tanks create drag, reducing speed and maneuverability. You want to jettison them as soon as possible, preferably before entering combat. But Shafer notices that pilots frequently land with 10, 15, sometimes 20 gallons still in the drop tanks. He asks Lieutenant James Goodson, one of the squadron's most aggressive pilots, why. Goodson explains, "The fuel selector valve is a pain. You've got 3 positions: left external, right external, or internal. Standard procedure is burn left external, switch to right external, burn that, then switch to internal. But if you're in combat, you're not thinking about fuel management. You're thinking about not dying, so most of us switch to internal fuel early. We know we have 85 gallons in the main tank. That's our combat reserve. The externals become emergency backup if we take damage or run into headwinds." Shafer does the math. If pilots routinely land with 15 gallons per drop tank remaining, that's 30 gallons of usable fuel being wasted on every mission. At 65 gallons per hour cruise consumption, 30 gallons equals 27 minutes flight time, approximately 130 additional miles of range. The solution seems obvious. Get pilots to fully drain their external tanks before switching to internal fuel. Shafer mentions it to Captain Donald Gentile, the squadron operations officer. Gentile shakes his head. "Sergeant, Have you ever been in combat at 25,000 feet with 3 FW 190 seconds trying to kill you? You're not thinking clearly. Your hands are shaking. Your pulse is 140. The fuel selector valve requires you to look down into the cockpit, locate the selector, and make sure you're turning it to the correct position. If you accidentally select the wrong tank, one that's already empty, your engine quits. Now you're in a dead glider with German fighters shooting at you. Every pilot knows the internal tank has fuel. That's the tank we trust. The externals are aluminum cans bolted under the wings that we'll jettison anyway. Nobody's going to risk their engine quitting in combat just to squeeze out the last few gallons. It's a rational explanation. Shafer accepts it. But the wasted fuel bothers him. 30 gallons per mission, 50 sorties per day across the 4th Fighter Group. That's 1,500 gallons wasted daily. Over a month, 45,000 gallons. Not a catastrophic amount, but frustratingly inefficient. Then on February 20th, 1944, 8 Fighter Command launches the first fighter sweep over Berlin, Operation Argument, also called Big Week. The mission pushes the P-51's range to its absolute limit. Fighters escort bombers 600 miles into Germany, engage enemy fighters over the target, and struggle back to England on fumes. 4 pilots from the 4th Fighter Group don't make it, not shot down, not killed, just out of fuel. 3 crash land in Allied-held territory. 1 ditches in the Channel and is rescued. All 4 pilots survive, but all 4 aircraft are lost. Major Blakesley is furious. Not at the pilots, at the math. We're losing aircraft because we're 50 miles short of the range we need. 50 miles? That's 20 minutes flight time. That's nothing, but it's the difference between landing safely and ditching in the Channel. Shafer hears about this and thinks about those 30 gallons left in drop tanks after every mission. 27 minutes flight time, 130 miles. Exactly the margin the fighters need. But pilots won't fully drain external tanks because the fuel selector valve is awkward and switching tanks in combat is dangerous. The problem isn't the fuel, it's the fuel management system. On February 23rd, Shafer is conducting a post-flight inspection on Mustang P-51B, serial number 43 to 12434. The aircraft belongs to Lieutenant Vermont Garrison. It landed with approximately 18 gallons combined remaining in both drop tanks, verified by Shafer physically checking the tanks with a measuring rod. He's standing under the wing, looking at the drop tank, when he has a thought. What if you didn't switch tanks at all? What if all the fuel fed into one tank and that tank fed the engine? Pilots wouldn't need to touch the fuel selector until the externals were completely dry. The engineering problem is straightforward. The P-51 has 3 separate fuel systems. Left external tank, right external tank, internal tank. Each has its own fuel lines running to a selector valve in the cockpit. The pilot manually chooses which system feeds the engine. What if you connected the external tanks to the internal tank? Let gravity feed the external fuel into the internal tank, keeping it topped off. The engine always draws from internal. Externals drain automatically. Pilot never touches the fuel selector until both externals are dry. Shafer sketches this in his notebook. The internal tank is located directly behind the engine, below and forward of the cockpit. The external tanks hang under the wings, significantly lower than the internal tank when the aircraft is on the ground, but at roughly the same height when the aircraft is flying level. That's the problem. Gravity feed requires the source tank to be higher than the destination tank. In level flight, the external and internal tanks are at the same altitude, no gravity differential. Fuel won't flow, unless the internal tank is lower, or the external tanks are higher, or both. Shafer walks around the P-51, studying its fuel system. The internal tank sits in a fuselage cavity behind the engine firewall. It's a metal tank, riveted construction, held in place by mounting brackets. The tank's top is approximately level with the bottom of the cockpit. The external drop tanks mount to hard points under the wings via quick-release shackles. When the pilot pulls the jettison handle, explosive bolts fire and the tanks fall away. Simple, reliable, combat-proven. But what if you connected a fuel line from each external tank to the internal tank? A physical fuel line that allowed fuel to gravity feed from externals to internal as long as the aircraft maintained level or climbing flight. The more Shafer thinks about it, the more feasible it seems. The external tanks already have fuel outlet fittings at their bottom. Those fittings connect to existing fuel lines that run to the wing route and then forward to the cockpit selector valve. What if you rerouted those lines? Instead of running to the selector valve, run them to a new inlet fitting on top of the internal tank. When the pilot starts the engine, fuel pump pressure draws from the internal tank as normal. But as the internal tank depletes, fuel from the external tank's gravity feeds into the internal tank, keeping it full. The pilot flies the entire mission without touching the fuel selector. The external tanks drain automatically. When both externals are empty, the internal tank has been kept full throughout the flight. The pilot can jettison the empty drop tanks and still have a full 85-gallon internal tank for combat and return flight. It's elegant, it's simple. It requires no complex engineering, no new components, no manufacturing. Just rerouting existing fuel lines and drilling one new fitting into the internal tank. There's one enormous problem. Modifying military aircraft without authorization is illegal. The P-51B's fuel system is designed and certified by North American Aviation. Any modification, preparing and narrating this story took us a lot of time, so if you are enjoying it, like this video, it means a lot to us. Now back to the story. Requires engineering analysis, testing, approval through procurement channels, and fleet-wide implementation directives. An enlisted mechanic cannot simply drill holes in fuel tanks and reroute fuel lines because he had an idea. That's destruction of government property. That's court-martial territory. But Shafer cannot stop thinking about those 4 pilots who ditched because they ran out of fuel 50 miles from home. He thinks about future Berlin missions, where range will be even more critical. He thinks about the 30 gallons wasted on every mission because pilots won't drain their external tanks. On February 25th, 1944, Shafer makes a decision. He's going to build his modification in secret, test it on his own aircraft, and if it works, present the results to his commanding officer. If it fails, he'll remove the modification, and nobody needs to know. If it works, maybe somebody will listen. The aircraft he chooses is P-51 B-43-12434, the same aircraft he was inspecting when the idea occurred to him. It's Vermont Garrison's regular mount. Garrison is deployed on a 48-hour pass. The aircraft is scheduled for a 50-hour maintenance inspection, meaning Shafer has legitimate reason to have it in the hangar with panels removed. Shafer recruits 2 other mechanics he trusts, Corporal James Chen, fuel systems specialist, and Private First Class Mike Torres, sheet metal work. He doesn't tell them the full plan initially. He just says he wants to experiment with fuel line routing. Working after hours over 3 nights, they make the modification. Step 1. Fabricate an inlet fitting for the top of the internal fuel tank. Torres cuts and shapes aluminum sheet metal, creating a circular fitting with internal threading. Chen drills and taps the hole in the top surface of the internal tank, then installs the fitting with tank sealant and rivets. Step 2. Reroute the external tank fuel lines. Normally, these lines run from the wing hardpoints forward to the fuselage, then to the cockpit selector valve. Shafer disconnects them from the selector valve and extends them upward, connecting them to the new inlet fitting on the internal tank via a Y-junction. Step 3. Install check valves. The modification requires one-way check valves to prevent internal tank fuel from flowing backward into external tanks. Chen installs 2 check valves in the modified fuel lines, ensuring fuel can only flow from external to internal, never reverse. The work is crude by engineering standards. No precision machining, no CAD drawings, no stress analysis. Just 3 mechanics with hand tools, working by flashlight, making it up as they go. On February 28th, the modification is complete. Now comes the terrifying part. Ground testing. Shafer fills both external tanks with fuel, leaves the internal tank half full, and runs the engine at idle in the hangar. Chen monitors fuel levels with measuring sticks. Torres watches for leaks. Shafer watches the fuel pressure gauge. For the first 10 minutes, nothing happens. The engine draws fuel from the internal tank normally. The fuel level drops slowly. Then Chen shouts, "It's working! Internal tank level is rising." Shafer checks. The internal tank, which was at 40 gallons, is now at 48 gallons. Fuel from the external tanks is gravity feeding into the internal tank faster than the engine is consuming it at idle power. They run the engine for 30 minutes. No leaks, no pressure anomalies. The internal tank stays full as long as the external tanks have fuel. When they shut down and drain the external tanks, the internal tank has increased to 82 gallons, nearly full. The modification works on the ground. But ground testing and flight testing are completely different. An aircraft in flight experiences vibration, G-forces, altitude changes, and temperature variations that could cause the modification to fail catastrophically. Shafer needs a flight test, but he can't ask a pilot to fly a modified aircraft without authorization. That puts the pilot's life at risk and makes them complicit in an illegal modification. So on March 2nd, 1944, Shafer does something even more insane. He decides to fly it himself. Technical Sergeant Robert Shafer is not a pilot. He has never soloed an aircraft. He has never received flight training. The closest he's come to flying is sitting in the cockpit during ground engine runs. But he's watched pilots start P-51 seconds hundreds of times. He's listened to them describe takeoff and landing procedures, and he's desperate enough to try. On March 2nd, 1944, at 0430 hours, before dawn, Shafer arrives at the flight line. The base is quiet, no scheduled missions today due to weather. The hangars are empty, except for a few maintenance crews on overnight duty working in different buildings. P-51 B43-12434 sits on the hard stand, fueled and ready. Shafer has already completed his unauthorized modification. Now he needs to test it in flight. His plan is simple and completely insane. Start the engine, taxi to the runway, take off, fly a circuit around the airfield at low altitude, and land. Total flight time, maybe 15 minutes. If the fuel system works, he'll know. If it fails, he'll know that too, right before the engine quits and he crashes. Shafer climbs into the cockpit. His hands are shaking. He's wearing a flight suit he borrowed from the squadron equipment room, plus a parachute he has no idea how to use properly. He's memorized the engine start checklist, but memory and reality are different things. Battery switch on, fuel boost pump on, mixture rich, throttle cracked 1 inch, propeller full forward, magnetos both, primer 4 shots, energizer engaged. The Packard Merlin V16507 engine coughs once, twice, then roars to life. 12 cylinders, 1,490 horsepower, shaking the entire airframe. The sound is incredible, overwhelming. Shafer has heard it 1,000 times from outside the aircraft. Inside, it's different. It's terrifying. He taxis slowly, awkwardly. The P-51's tailwheel steering is sensitive. He nearly runs off the taxiway twice, but he makes it to the runway threshold. No tower control at this hour, no clearance required. Just an empty runway stretching into darkness. Shafer advances the throttle. The Mustang accelerates. The tail comes up. Suddenly, he can see forward over the nose. Airspeed indicator climbing. 60 miles per hour. 80 miles per hour. 100 miles per hour. He pulls back on the stick, and the aircraft leaps into the air. He's flying. An unauthorized mechanic in an unauthorized flight in an illegally modified aircraft. If he survives the next 15 minutes, he's facing court-martial. If he doesn't survive, nobody will ever know what he was trying to prove. Shafer climbs to 1,500 feet and levels off. Now comes the test. The fuel selector is currently set to internal tank. According to his modification, the external tanks should be automatically feeding fuel into the internal tank, keeping it full. He looks at the fuel gauge. Internal tank reads 82 gallons, nearly full. That's consistent with ground testing, but the gauge could be malfunctioning. The only way to know for sure is to burn fuel and see if the internal tank stays full. Shafer circles the airfield for 20 minutes, occasionally advancing throttle to higher power settings. Every 5 minutes he checks the fuel gauge. Internal tank, 81 gallons, then 80, then 79. It's dropping slowly, much more slowly than it should. At cruise power, the Merlin burns approximately 50 gallons per hour. After 20 minutes at cruise, the internal tank should have dropped from 82 gallons to approximately 65 gallons, a loss of 17 gallons. Instead, it's dropped only 3 gallons. The math confirms it. The external tanks are feeding fuel into the internal tank, replacing what the engine burns. The modification works in flight. Shafer's hands are still shaking, but now from excitement rather than fear. He lines up for landing, reduces power, drops flaps, and somehow gets the Mustang back on the runway without crashing. The landing is terrible, bouncing twice, but he's down. He taxis back to the hard stand, shuts down the engine, and sits in silence. He's just proven that his modification works. Now he has to convince someone in authority to authorize it. At 0800 hours, Shafer reports to Captain Donald Gentile, the squadron operations officer. Gentile is a legend. 21.83 confirmed kills, one of the most skilled fighter pilots in the European theatre. He's also notoriously impatient with mechanics who waste his time. Sir, Shafer begins, I need to show you something on Vermont Garrison's aircraft. Gentile follows him to the hard stand. Shafer points out the modified fuel system, explaining how it works. Gentile listens without expression. When Shafer finishes, Gentile asks, Did you get authorization for this modification? No, sir. Did you test it? Yes, sir. How? I flew it myself this morning, sir. Gentile stares at him. You're not a pilot. No, sir. You flew a modified aircraft without authorization, without training, without clearance. Yes, sir. Sergeant? You realize I could have you court-martialed for about 6 different violations? Yes, sir, but it works. The modification solves the range problem. Pilots won't have to. Switch fuel tanks manually. The external tanks drain automatically. We gain approximately 30 gallons of usable fuel per mission. That's 130 additional miles of range. Gentile walks around the aircraft, examining the modification. He's quiet for a long time. Finally, he says, I'll fly it myself. If it works like you say, I'll take it to Major Blakesley. If it doesn't, you're facing charges. Clear? Yes, sir. That afternoon, Captain Gentile takes P-51 B-43 to 12434 on a 2-hour patrol mission. When he lands, he immediately finds Shafer. It works perfectly. Internal tank stayed full the entire mission. I didn't touch the fuel selector once. When I jettisoned the drop tanks, the internal tank was still at 84 gallons. I've been flying Mustangs for 8 months, and never landed with that much fuel remaining. March 3rd, 1944. Major Don Blakesley, commander of the 4th Fighter Group, stands in the hangar looking at Shafer's modification. Gentile has briefed him on the concept and the test flight. Blakesley asks technical questions. How did you seal the fuel line connections? What prevents backflow? What happens if one external tank is damaged and leaking? Shafer answers each question. Blakesley is silent for several minutes. Then, how long to install this modification on all aircraft in the group? 45 minutes per aircraft, sir. Working with a 3-man crew, we could modify the entire group in 4 days. And this modification gives us how much additional range? Approximately 130 miles, sir. Enough to escort to Berlin and back with combat reserve. Blakesley makes a decision that will change the air war. Sergeant, you're either brilliant or insane, possibly both. I'm authorizing this modification for the entire 4th Fighter Group. You have 4 days. We have a Berlin escort mission on March 8th. Every aircraft needs this system installed before then. Shafer and his team work around the clock. They fabricate inlet fittings, reroute fuel lines, install check valves. By March 7th, all 48 P-51Bs in the 4th Fighter Group have the modification. March 8th, 1944. The first bomber escort mission to Berlin. 73 P-51 Mustangs from 8 Fighter Command take off from bases across England. 48 of them belong to the 4th Fighter Group. Equipped with Shafer's modification, Captain Gentile flies P-51 B-43 to 12434. He crosses into Germany at 25,000 feet, escorting B-17 seconds toward Berlin. His external tanks drain normally, feeding into his internal tank exactly as designed. By the time he reaches Berlin, both externals are empty, and he jettisons them. His internal tank reads 83 gallons, nearly full. Over Berlin, German Bf 109 seconds attack. Gentile engages, destroying 2 enemy fighters. The combat lasts 18 minutes at high power settings, burning approximately 36 gallons. He still has 47 gallons when the bombers turn for home. The return flight is uneventful. Gentile lands at Debden with 12 gallons remaining. Under the old system, he would have run out of fuel 80 miles from home. Across the 4th Fighter Group, the results are identical. Every pilot equipped with Shafer's modification completes the mission with fuel to spare. 0 aircraft lost to fuel exhaustion. The impossible mission is suddenly possible. Within days, V-8 Fighter Command Headquarters hears about the modification. Engineering officers arrive to inspect it. Their initial reaction is horror. This modification was installed without proper engineering analysis, without stress testing, without approval. It violates procurement procedures and aircraft certification standards. But the operational results are undeniable. The modification works. It's already installed on 48 aircraft, and it solves the single biggest limitation preventing fighter escort to Berlin. On March 15th, 1944, General William Kepner, commanding 8 Fighter Command, makes a decision. Authorize immediate fleet-wide implementation. Get North American aviation engineers to formalize the design, but don't wait for them. Every P-51 inches England gets this modification within 2 weeks. By April 1944, over 400 P-51 Mustangs in the European theatre have Shafer's fuel system modification. The strategic impact is immediate. Between March and May 1944, 8 Fighter Command flies 28 escort missions to Berlin. German fighter losses over Germany in that period: 2,262 aircraft destroyed. The Luftwaffe is systematically annihilated, losing pilots faster than training schools can replace them. By D-Day, June 6, 1944, the Luftwaffe is effectively defeated as a strategic force. Allied aircraft operate over Normandy with near impunity. The invasion succeeds in part because German air power has been destroyed in the skies over Berlin, and that destruction began with an unauthorized modification installed by a mechanic who was never supposed to redesign anything. Technical Sergeant Robert Shafer receives the Distinguished Flying Cross in May 1944, despite never being an authorized pilot. The citation reads, "For extraordinary achievement while participating in aerial flight." Sergeant Shafer's innovative fuel system modification increased fighter aircraft range by 130 miles, enabling escort missions to Berlin and contributing decisively to Allied air superiority over Europe. He's also quietly promoted to Master Sergeant and transferred to Wright Field, Ohio, where Army Air Force's engineers want him to work on other aircraft modifications. After the war, he returns to Ohio, takes over his father's garage, and never speaks publicly about his wartime service. In 1982, a military aviation historian researching P-51 Mustang modifications discovers Shafer's story in declassified maintenance records. He contacts Shafer, now 62 years old, and asks for an interview. Shafer declines. "I just fixed a problem. That's what mechanics do." The historian presses, "Your modification changed the air war. Without it, escort to Berlin would have been impossible." Shafer thinks for a moment, then responds, "If I hadn't thought of it, somebody else would have. The solution was obvious once you looked at the problem correctly. I just happened to be the one looking." But that's not quite true. Thousands of mechanics worked on P-51 seconds in 1944. Hundreds of pilots complained about range limitations. Dozens of engineers studied the fuel system problem. Only one person, an unauthorized, non-engineering sergeant from Ohio, actually solved it. The lesson resonates across decades. Expertise matters, but so does perspective. Sometimes the person closest to the problem, the one actually working with the machinery every day, sees solutions that experts miss. Sometimes the best innovations come not from designers, but from maintainers. And sometimes the most important breakthroughs require someone willing to break rules, risk court-martial, and fly an illegally modified aircraft into the dawn sky to prove a point. Charles Goodeve invented the hedgehog by questioning anti-submarine doctrine. Conrad Waddington revolutionized maintenance by challenging preventive maintenance orthodoxy. Robert Shafer extended fighter range by doing something nobody authorized him to do. The pattern is consistent. The greatest innovations often come from people who aren't supposed to innovate, who lack credentials, who ignore proper channels, and who have the audacity to believe their simple idea might actually work. In 1944, that audacity helped win World War II, and it started with a mechanic standing under a P-51's wing, wondering why everyone accepted 30 gallons of wasted fuel on every mission when the solution was obvious. Sometimes genius isn't about being the smartest person in the room. It's about being the only person in the room willing to question why things are done the way they've always been done. Robert Shafer questioned it, and 1,650 miles to Berlin became possible. Up next, you've got two more standout stories right on your screen. If this one hit the mark, you won't want to pass these up. Just click and check them out, and don't forget to subscribe and turn on the notification bell so you don't miss any upload from us.